How do we understand motion that repeats in cycles? And how do variables like mass, length, and spring constant affect the motion of an oscillator? These are the questions students explore in Investigation 14A, Oscillators. A pendulum and a mass on a spring are both good examples of oscillators, or systems that exhibit repetitive behavior. This investigation looks at how the periods of these oscillators are affected by physical variables like mass, length, and spring constant. For part 1, assemble the equipment with the hanger at the top of the tripod. Tie the string to the hanger and add 5 washers to the mass hanger. To start the pendulum swinging, move the pendulum bob to the side and allow it to swing freely. Once it's swinging, use the stopwatch simulation in the e-book to measure the time it takes the bob to complete one full cycle of motion, or 1 period. Once students are comfortable measuring the period of their pendulum, they then manipulate the mass of the pendulum bob, the length of the pendulum, and the amplitude of the pendulum swing to see how each variable affects its period. Students should manipulate these variables one at a time. When manipulating the amplitude of the pendulum swing, use the angle indicator behind the string to measure the amplitude value in degrees. Students can tabulate all of their data in Table 1 in their handout, and then use that data to answer the questions. Students should recognize that changing the mass of the pendulum bob or the amplitude of the swing has no effect on the pendulum's period. Students should also recognize that changing the length of the pendulum does affect its period, which decreases as length decreases. For part 2, replace the string with the stiffest spring and place 6 washers on the mass hanger. Students use a ruler to measure the height of the top washer while the masses are still. This is the equilibrium height of the mass and spring system. Students can start the system oscillating by displacing or raising the mass and releasing it. Measuring the period of the oscillating system is done the same way using the stopwatch simulation in the e-book. Once students are comfortable measuring the period of their mass and spring system, they then manipulate the mass of the pendulum bob and the amplitude of displacement to see how each affects the period of oscillation. Finally, students swap the stiff spring with a softer spring to test the effect of spring constant on the period of the system. Students will find that the period of the mass and spring system is not affected by displacement amplitude, but is affected by changes in mass and changes in spring constant. Students will find that the period of the system increases as spring constant decreases and also increases as mass increases.